Friends, welcome to my YouTube channel, Clinical Biochemistry by Dr. P.K. Prabhakar. Today we are going to discuss about the difference between the reducing sugar and non-reducing sugar. So first we will learn and then we will talk about some of the structures. We will see some of the structures of the reducing sugar and non-reducing sugar, how they are different from each other and what is the main characteristic differences there. So if you see the definition of reducing sugar, the sugar which is having a power to reduce someone else or some other molecules. So that sugar we are calling normally a reducing sugar. And a sugar carbohydrate which does not have any power to reduce other molecules, we are calling non-reducing sugar. Normally we are knowing oxidation reduction. It will be because of either movement of oxygen, movement of hydrogen or movement of electron. Here reducing sugars have a power, have a capacity to donate electron to other molecule. So sugar itself gets oxidized and in response the molecule which gets electron from the sugar will be reduced. So that's why it is called as reducing sugar. So we are going to see the difference between the reducing sugar and non-reducing sugar. So reducing sugars acts as a very good reducing sugar. It is having a very good power of reducing sugar, so reducing agent, so it can reduce other molecules, whereas non-reducing sugar does not have any kind of capacity to reduce other molecules. Why this power they can reduce works as a reducing agent? Because they have a power to donate electron to other molecules, whereas they don't have power to donate electron, so they cannot donate electron to other molecules. Any sugar which we are normally called reducing sugar, that sugar should have free aldehyde group or free ketonic group. Means a carbohydrate which is having free aldehyde or free ketonic groups is working as a reducing sugar, whereas non-reducing sugar does not have free aldehyde or free ketonic group. All the reducing sugars normally give all positive reactions for the various biochemical tests, which test we will foresee in the further lectures. So reducing sugar will give us positive reaction for the Benedict test, Benedict reactions, failing reactions and the tolerance reactions, whereas non-reducing sugars will give us negative result for all the three tests: Benedict reagents, Benedict reactions, failing reactions and tolerance reactions. Example, if you see it, all the monosaccharides and most of the saccharides are reducing sugar, whereas non-reducing sugars are all the polysaccharide plus few disaccharides. Those disaccharides are sucrose, trehalose. So all the monosaccharides and disaccharides are reducing sugars except few disaccharides which is not reducing sugar, whereas all the polysaccharides and some of the disaccharides like sucrose and trehalose are non-reducing sugars. Now we will see structurally how they are different, how reducing sugar and non-reducing sugar works. Friends, basically you might have seen the structure of glucose. Glucose structure is normally like this one. This is glucose molecules. We are calling it D-glucose. This is D form of glucose. This is the open chain of glucose. If this is going to cyclic forms, so in that case, this first carbon which is now asymmetric in the nature. Is why it is this is symmetric in nature. Why it is symmetric in nature? Because it is having a double bond. And some lectures we will talk about how symmetricity and asymmetricity we can differentiate. So this carbon is symmetric in nature because of the presence of the double bond. So any carbon which is having a double bond are symmetric in nature. So this carbon normally forms a bonds with fifth carbon. This is the fifth carbon. So they are going to form a cyclic structure from the carbon number 1 to carbon number 5 and results in the structure of so this is my carbon number 1, this is carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. If you see here, so there is a bond between carbon number 1 and carbon number 5. So this is my C5 and this is C1. So the C1 which was aldehyde here, that came here. This is the aldehyde carbon. So this aldehyde carbon was symmetric here, but at this place this carbon becomes asymmetric. So this is carbon number 1 which becomes asymmetric. Why it is asymmetric? Because all the 4 bonds associated with this one, this carbon is different. Like this side it is having hydrogen, this is having OH, this is having CH, OH and number of other molecules. This side it is directly associated with oxygen. So 4 bonds are different bonds. That's why it is the asymmetric carbon. So the carbon which was symmetric when glucose was in open chain structure becomes asymmetric when it forms a cyclic structure. So that carbon is called as anomeric carbon. This is in case of glucose. If we'll see in case of fructose, so in case of fructose, everything will be same. 1, 2, 3, 4. At this place, this is fructose. So in case of fructose, this carbon number 2 is going to form a bond with fifth carbon. So the ring will be of 4 carbons ring, and ultimately it will be result in so this is carbon number 1 which is here, this is carbon number 2 which is here, this is carbon number 3, 4, 5. So C3, C4, C5 and C6. Now if you look at the carbon number 2, this carbon. So this carbon is having a double bond. It means again this carbon is symmetric in nature. But when this forms a cyclic structure, as we are seeing here, C2, this carbon is having 4 different bonds associated with that one. Here it's one side it is having CH2OH, second side it is having hydrogen, third it is having CH2OH, and fourth side it is associated with oxygen. So the C2 which was symmetric here becomes asymmetric here. So this is called as anomeric carbon here. Now the definition of reducing sugar is, if a sugar whose anomeric carbon is having free oxygen available, which can bind, which can react, which can donate electrons. So if free oxygen for the reaction is available at anomeric carbon, we will call it reducing sugar. If that anomeric carbon lacking in oxygen, we will call it non-reducing sugar. So as we are seeing here, in case of this one. So this carbon is directly, it does not have this carbon directly, they don't have they have a direct associated oxygen. Similarly, we had seen in case of glucose also, it was like this one, HOH. So this was anomeric carbon, it is an OH. So directly oxygen is there. So means glucose and fructose works as a reducing sugar. Now, if you see a disaccharide which is sucrose, how sucrose is non-reducing sugar? Like sucrose is this is C2 of fructose, this is C3, this is C4, this is C5, this is C6. Here it is C1, C2, C3, C4, C5 and C2, well, this is C6. So this was the anomeric carbon here and this was the anomeric carbon here. This has OH here and this has OH here. But when these two combine together, both the OH reacts and forms a bond, ester bonds. By they removes water. So now at this place no free oxygen is available at anomeric carbon. So sucrose works as non-reducing sugar, whereas glucose alone was reducing sugar because oxygen was available. Fructose alone was working as a reducing sugar because oxygen was available there. But when these two combine together, they works as sucrose works as non-reducing sugar. So thank you very much. Hope you have understand and like the video. In case you have any query, any questions, please write in the comment box. If you like the video, press like button and share it. If you want more such video, please subscribe my channels. Hopefully I will fulfill all your requirements. Thank you very much.